Welcome to this explainer. Okay, today we are unlocking the fundamental ways a computer program actually holds on to information and how it uses that info to make decisions. Think about your favorite app or video game for a second. Every score, every single player name, that timer counting down in the corner, that's all data. But how does Python actually keep track of the whole shebang? Well, that is exactly what we're going to figure out today.
Here is our roadmap for today. First, the power of variables. Second, meet the data types. Third, type-aware reasoning. Fourth, we'll do a quick concept check. And finally, we'll wrap up with the big takeaway. Let's dive in.
Part 1, the power of variables. These are basically your code's labeled containers. Now, without variables, your computer program would literally have the memory of a goldfish. You can think of a variable just like a labeled container that's built to hold specific data. Imagine a physical cardboard box sitting in your room. You grab a Sharpie and write high score right on the outside of it. That label, high score, is your identifier. That part never changes. But the number you actually put inside that box, that can change all the time as you play the game. You might take out a 10 and swap in a 50. The contents are always changing, but the container's name stays exactly the same. So here's the really crucial point. When you create these containers, using clear naming conventions makes your code so much easier for you and anyone else to read and debug later. I mean, if you label your box with just the letter X, and then you come back to your code 3 weeks later, you are going to have absolutely no idea what X is supposed to hold. Is it a name, a speed, a score? Who knows? But if you name your variable player_health, you instantly know what belongs in there. Clean, descriptive names are absolutely the hallmark of a great programmer. Moving right along to part 2, meet the data types. Let's look at what actually goes inside those containers. Python is pretty smart and automatically handles different data types, but you really need to know the 4 fundamental types you'll be putting into your variables. These are essentially the building blocks of almost everything you'll ever create in Python. We've got integers, floats, strings, and booleans. Let's break these down so you know exactly which tool to grab for the job. First up, let's compare our numbers. Integers are just your standard, everyday whole numbers. Floats, on the other hand, represent anything with a decimal point. Now, you might be wondering, why does a computer even need 2 different types of numbers? Well, think about the real world for a second. If you're counting the number of lives a player has left, you'd use an integer, right? You can't exactly have 2.5 lives. It's just 1, 2, or 3. But if you're programming a stopwatch for a high-speed racing game, you need incredible precision. You need, say, 12.45 seconds, and that requires a float. Next, we have strings. These are just words or text data. The key here is you always wrap them in quotation marks so Python knows their text, like a username, a super secret password, or a message popping up on the screen. Then we have booleans. These act exactly like a simple on-off switch for true or false. They are the logic centers of your program. Is the game over? True. Does the player have the secret key? False. They seem really simple, but they are incredibly powerful for making decisions in your code. All right, part 3, type-aware reasoning. Let's get into how Python actually thinks. When you're manipulating data, you're usually following this precise little cycle. You create a clearly named variable, you assign it a specific data type, and then you perform an operation on it. Python takes over from there, looking at the data types and automatically processing them based on its own built-in rules. And this brilliantly illustrates what happens when we start combining them. Adding numbers does regular math. Adding strings joins text together. But mixing them, that sets a huge trap. Look, if you take the integer 5 and add the integer 5, Python does the math and gives you 10. Makes perfect sense. But what if you add the string snow and the string ball? Python doesn't try to do math with text. Instead, it just smashes them together to create snowball. It's a completely different operation simply because the data type changed. And right here is exactly why type-aware reasoning matters. If you try to tell Python, hey, add the integer 5 to the string apples, Python literally stops dead in its tracks. It throws an error and your code breaks simply because it can't mathematically add a number to a word. As a programmer, you have got to be aware of what is inside your containers to avoid setting these exact types of traps for yourself. Okay, part 4, quick concept check. Time to test your knowledge. So think back to our 4 categories for a second. If we need to store a word, like a person's name, which specific type of container do we need? Is it an integer, a float, a string, or a boolean?
If you guessed a string, you hit the nail right on the head. Strings are designed specifically to handle text, so whenever you're dealing with letters, words, or full sentences, you're always going to wrap them in quotes and put them safely into a string variable. Let's try just one more. Which data type is perfect for answering a simple yes or no question in your code? Remember that light switch analogy?
Yup, that's right. A boolean is the exact data type you need for true or false logic. If you're checking if a player has reached level 10, well, that variable is going to hold a boolean for sure.
Finally, part 5, the big takeaway. Let's master these Python variables. Always remember this golden rule when designing your Python projects. Clean code starts with clear data. If you don't know what kind of data is living inside your variables, I promise you your code is going to be messy, buggy, and super frustrating to fix.
Mastering how Python handles data types is literally the single best way to prevent errors and build reliable software. By choosing descriptive variable names and matching them with the perfect data type, whether that's an integer for a score, a float for a timer, a string for a name, or a boolean for a switch, you take complete, total control over your program. Right now, those variables are sitting there completely empty, just waiting for your instructions. So, how will you use these data types to solve real-world problems? What are you going to build next? Keep exploring, keep coding, and I'll catch you in the next explainer.